Hello everyone, I welcome you all to this video lesson. Have you ever had the habit of visiting tourist places, especially in the northern parts of India? Some may have gone, some may have not, but I hope everybody would have heard about Qutub Minar. Qutub Minar is made up of iron pillars, the two rust-free iron pillars. What is rusting? Rusting is a process in which iron reacts with atmospheric oxygen and water to form hydroxides of iron and also oxides of iron, which forms a reddish layer on the iron, which actually denatures the original nature of iron. But over 1500 years, for about 1500 years, the Qutub Minar building is standing as a rust-free iron pillars. But everything around us is not so permanent as Qutub Minar. Everything around us keeps on changing. For example, have you ever tasted coffee? I hope everyone would have. So, milk can be turned into coffee, tea or even curd, but with different forms of conditions. So now, everything around us keeps on changing. So, today in this video lesson, we are going to discuss about the lesson Changes Around Us from 8th standard. Okay, before in the 6th or 7th standard itself, we would have learned something about change and types of changes. Okay, what are the two types of changes? Physical change and chemical change. Physical change. A physical change is nothing but it is a change which is very reversible and it will not form any new products. But in case of a chemical change is an irreversible change, but in that case a new product is expected or it is formed. So this is the basic difference between a physical change and a chemical change. So for example, if I take a paper and fold it or even crush it, it is a physical change. But if I take a paper and burn it, it is a chemical change because it results in the formation of new product, that is smoke, which is nothing but carbon dioxide. So this is the basic difference between a physical change and a chemical change. In depth, we are going to discuss about chemical change. So chemical change can also be called as a chemical reaction because in chemical reaction, two reactants, that is reactant molecules, react to form product. That is called a chemical reaction. So typically, chemical change can also be called as chemical reaction. But for a chemical reaction to take place, there are certain specific conditions that is very much needed. So today, in this video lesson, we are going to cover three main topics, that is the specific condition needed for a chemical change to occur, and what are the effects of a chemical change, and what are the productions of a chemical change. These are the three main topics we are going to deal with. First, to deal with specific conditions needed for a chemical change. There are many several conditions that are needed for a chemical change. The first one is physical contact with the reactants. For example, if I give you a matchbox, and what are the constituents of matchbox? A matchbox may contain a matchbox and a matchstick. In the matchbox, there are chemicals on the either side of the matchbox, and in the matchstick, there is a chemical at the point of the matchstick. I am asking you to burn the matchstick without any physical contact, without rubbing the chemicals each other. How can we do? Even you or I cannot do. Only when both physical components rub each other, we can bring fire out of the matchbox. So this is an example for physical contact of the reactants. So for certain chemical reactions to take place, we need physical contact of the reactants. Another one example is burning of wood. In the case of burning of wood, the wood comes in contact with the atmospheric air to bond to form smoke. So some reactions take place only when the reactants are in physical contact with each other. This is the first specific condition. And the next condition is reactants in solution phase. Certain reactants, only when they are in solution phase, undergo some chemical reaction. For example, if I take silver nitrate in a test tube and sodium chloride in a test tube and mix it along in a common test tube, but both are taken in a solid phase. When I expect some chemical reaction to take place, there will be no chemical reaction. But in the same case, when I take both the chemicals but in a liquid phase, that is silver nitrate and both sodium chloride are in the liquid phase and pour it in the same test tube, I can see what precipitates of sodium nitrate settling down. So some of the reactions need some solution phase to undergo reactions. Another one is electricity. Electricity is very important these days because without electricity we will not serve literally we will not serve these days because without light, fan, so it is very impossible to think about it. So electricity is very important and many chemical reactions are undergone through electricity. For example, when I take water and with a dilute amount of acid and electrolyze it, I can see the evolution of hydrogen and oxygen from it. It is an industrially important process also. And another example is if I take in brine solution. Brine solution is nothing but sodium chloride solution, and if I electrolyze it, I can see the evolution of chlorine gas. It is very industrially important preparation of chlorine gas. So some reactions needed electricity for its reaction is called as electrolysis or electrochemical reactions. Next, heat energy. In some cases, heat energy is very much important for a chemical reaction to undergo. For example, slate lime. Okay, for example, not slate lime, we can take limestone. If I heat limestone, it will evolve us or it will give us, if I heat limestone, it will give us quicklime. It is also an industrially important process because limestone is very much used in the buildings and construction of everything. Next one is if I take a lead nitrate, it involves in the evolution of nitrogen gas while when heating. So only when heated these reactions takes place. Next important condition is light. As soon as I said about light, you can think of photosynthesis. How photosynthesis happens, everybody would have known. Using the sunlight, plants convert carbon dioxide and hydrogen to starch, which is the very most important for food preparation. Even without the plants producing starch, we cannot eat any food because we are dependent on plants for food. So light is very important for the life-giving chemical reaction. So next one is catalyst. Okay, catalysts are also very important for a chemical reaction to take place, but not in many cases because without catalyst also the reaction may undergo but at a very slower rate. A catalyst is a substance which enhances the speed of a chemical reaction. For example, Haber's process. Haber's process is a process which is used in the laboratory for the preparation of ammonia because ammonia is a rich fertilizer, nitrogen rich fertilizer. So Haber's process is a very important chemical process. 1:3 ratio of nitrogen and hydrogen combines to form ammonia. In that reaction, solid iron is used as a catalyst. So it is very much used for the increasing the speed of the reaction. So these are certain important specific conditions for a chemical reaction to take place. What are they? Let us revise. They are physical contact with the reactants, reactants in solution phase, electricity, heat, light and catalyst. Among this, not only these things, but also some of the more specific conditions are also necessary. But these six are very important necessary conditions for a chemical reaction to take place. Okay, first topic is dealt with. And next we are going to see about what are the effects that is produced after a chemical reaction. There are that is separated into two effects. They are biological effects and environmental effects. Biological effects. Under the biological effects, we are going to discuss three topics, and they are: the first one is spoilage of food. Have you ever noted the food cooked in the morning is not so good? It is rotten, or it gives some false smell and odor in the evening. That is why because of the enzymes present in the food. So the enzymes catalyze some biochemical reactions within the food and denatures its structure. That's why it is getting spoiled. So that is spoilage of food is also a chemical reaction. And the next one is browning of apple. Have you ever noted when you cut the apples and leave it for some time, you can see the brownish color of the apple that is due to the chemical reaction called oxidation. That is because there is a compound in the apple or some fruits called polyphenol oxidase or tyrosinase which gets oxidized to form melanin pigments. That is the reason for the brown color in the apple. And the next one is rancidity of meat and fish. Rancidity is nothing but on the flesh of a fish or meat there is a compound called unsaturated fatty acids which when comes into contact with the atmospheric air or oxygen gets oxidated and results in a foul smell. called reactivity of fish and meat. These are certain biological effects of a chemical reaction. Coming to the environmental effects include production of pollution, that is pollution, and may also include rusting and tarnishing also. Coming about pollution causes when the physical, chemical and biological characteristics of our environment is changed or altered. It results in pollution. There are three major pollutions called air pollution, water pollution and land pollution. These three pollution causes very damage to not only human life but also animal life also. Then in case of air pollution, it even causes cancer in human beings. In case of water pollution, it causes waterborne diseases. In case of land pollution, it pollutes the land and it lacks the fertility of the land. It makes the land to lack its fertility itself. So these are the main causes of pollution. Next, rusting. As we have seen in the introduction itself, rusting is nothing but when iron reacts with atmospheric air and oxygen, forms its hydroxide forms. So those hydroxide forms a layer on the iron metal, which denatures the original nature of iron. This process is called as rusting. Next, tarnishing of metal. Tarnishing of metal means some metals may lose its glittering or lustrous property when oxidized to air. For example, your mother is wearing an anklet. The new anklet will be very bright and silver in color. But when it is getting older and older, it reacts with the atmospheric oxygen or atmospheric moisture to form iron oxides, that is a blackish color of anklet. So this is due to the chemical reaction between atmospheric oxygen and the silver in the anklet. Our next example is brass vessels in our home sometimes get green color in it. This is because brass contains copper and the copper reacts with atmospheric air and oxygens to form copper carbonates and copper hydroxides, which is literally green in color. So these are some of the effects of chemical reaction, that is environmental side and also biological side. And the last topic is productions. What a chemical reaction can give us as side products. First one is heat, production of heat. A chemical reaction which involves the evolution of heat is called as exothermic reaction. An example is when you have sodium hydroxide and put some water on it, you can observe the walls of the side tubes. You can observe some heat in the walls of the side tubes. So this is an example for production of heat. Then production of light. Take a test tube and put a magnesium ribbon in it and heat it in a Bunsen burner. You will see a spark of light. So this is an example for the reaction where heat is produced as a side product. Then production of sound. In some cases, for example, take sound maybe for a practical example, we can say Diwali crackers. So while we are cracking the Diwali crackers, we can have both light and sound as side products. Another example is take a test tube, put some magnesium and zinc in it, burn matchstick and bring in the mouth of the test tube. So we can hear a pop sound. This is due to the evolution of hydrogen from the test tube, because we have to add some dilute acids to the test tube also. Then the hydrogen will be evolved from the acid, so we can hear a pop sound. This is the production of sound. Then production of pressure. So you take a balloon and you can feel air in it, then you can tie it, then if you press it, what will happen? It will burst out. This is due to the pressure and the compression. This is a reaction where we can see production of pressure. So explosives and higher explosives and atom bombs, hydrogen bombs are example of the pressure due to the pressure between the reactants in the inside. It is explosive. So that's all. In this video, we have covered three main topics, that is specific condition that is needed for a chemical reaction to take place, and what are the effects of a chemical reaction, both the biological effect and also the environmental effect, and what are the side products produced in a chemical reaction. I hope you have all understood the concept. So thank you.